Hi everybody, this is Gordon. This is the beginning of a problem set on formula and composition calculations. The important thing to consider or remember is an empirical formula gives the relative number of atoms of different elements in a compound with the smallest set of integers or whole numbers. Also, we'll be using the idea of the mole. If an element or compound has a mass of so many atomic mass units, 1 mole of the same element or compound has the same mass in grams or any other unit of weight or mass. First question, what's the empirical formula of a hydrocarbon that on analysis gave the composition of carbon 85.63%, hydrogen 14.37%? The plan, we're going to find the grams of each, change that to moles, and use those moles to give us whole number ratios. If we start with 100 grams of compound, then 85.63% of that compound will be grams of carbon, and 14.37 grams of that compound will be hydrogen. We can convert that to moles of carbon by recalling that 1 mole of carbon has a mass of 12.011 grams. And the hydrogen, we remember that 1 mole of hydrogen has a mass of 1.008 grams. Doing the arithmetic, we find that we have for carbon 7.129 moles of carbon and 14.26 moles of hydrogen. To get whole number ratios, we divide all numbers by the smallest number that we have, in this case 7.129, so 7.129 divided by itself obviously is 1. That means that the whole number integer for carbon will be 1. We divide 14.26 by 7.129, we get 2, and that will be the whole number integer for hydrogen. So CH2 is the empirical formula. The next problem, a compound on analysis gave the following percent composition: potassium 26.57%, chromium 35.36%, oxygen 38.07%, and we're asked to find the empirical formula. We're going to do the same. We're going to start with 100 grams of compound, and that means that 26.57 grams of that 100 grams is potassium. And recalling that 1 mole of potassium has a mass of 39.01 grams, we find that we have 0.68 moles of potassium. Likewise, for chromium, we come up with 0.68 moles of chromium and 2.379 moles of oxygen. Dividing all numbers by the smallest number, 0.68, we come up with 3.5 for oxygen. So starting with that, we have KCr03.5, but these are all supposed to be whole numbers. So if we double everything, we get an empirical formula of K2Cr2O7 as the empirical formula for the compound. And that's that problem. Problem number 3. What is the percentage of iron in Fe2O3? First thing we want to do is we want to find out what the weight of the molecular mass of this compound is. So it's going to be 2 times the mass of oxygen plus 3 times the mass, 2 times the mass of iron plus 3 times the mass of oxygen. And we come up with 159.7 atomic mass units. The amount of iron in the compound is 2 times the atomic mass of iron, 2 times 55.85, which is 111.7 AMU. This allows us to say that the percent of iron in the compound is 111.7 AMU divided by 159.7 AMU. And we multiply that by 100 to get it into a percentage and come up with a final value of 69.94%. The fourth problem, how much calcium is in the amount of calcium nitrate that contains 20 grams of nitrogen? And so what we're going to do is first come up with the molecular weight for the compound, but a plan of attack first. CaCNO3 2 means that there are 2 moles of nitrogen for every 1 mole of calcium. The plan then, we're going to find the grams of nitrogen, change that to moles of nitrogen, then use our relationship to get to moles of calcium and then the grams of calcium. So we start off with the 20 grams of nitrogen. We recall that 1 mole of nitrogen has a mass of 14 grams. And from above, we have 1 mole of calcium for every 2 moles of nitrogen. That should be on the bottom. There are 40.1 grams of calcium for every 1 mole of calcium. And so if we multiply all these together, we're going to get an answer in grams of calcium. And so in the numerator, we have 20 times 1 times 1 times 40.1. And in the denominator, it's going to be 14 times 2 times 1. And when we do the math, we come up with 28.6 grams of calcium. Problem solved. The final problem in this set: how many tons of calcium phosphate must be treated with carbon and sand in an electric furnace to make 1 ton of phosphorus? Sound like a crazy problem, and you scratch your head and figure out what you want to do. But first thing, as always, molecular mass of the compound you're working with: 3 times the mass of calcium plus 2 times the mass of phosphorus plus 8 times the mass of oxygen. We get 310.24 AMU. How much of that is phosphorus? 2 times the mass of phosphorus is 61.94 AMU. So there's a relationship. 61.49 AMU phosphorus per every 310.24 AMU of calcium phosphate. It also means the same ratio in tons exists. So if we want 1 ton of phosphorus, we can use a relationship that we just calculated. We have 310.24 tons of calcium phosphate for every 61.94 tons of phosphorus. And when we do the math, pretty simple, just dividing 310.24 by 61.94, we come up with an answer of 5.01 tons of calcium phosphate. And the problem is solved. Thanks for watching.